Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 850. Please turn to it. 850. And today is our lesson number 113. Let's take a look at it. In problem number 12, the very first problem on the page, number 850, they give us a little grid system here with the grade and the distance. It says the results of a survey of 16 students at their school are given in the grid above. It shows the distance to the nearest mile that the students at various grade level must travel to school. According to the grid, which of the following is true? So there are 5 statements that are given to us. Apparently 4 of them are not true. Our job is to locate one statement that is true based on what we see on the grid system. So let's do that. We have 9th grade, 10th grade, 11th grade, and 12th grade. And we have 1, 2, 3, 4, 5, 6, 7, and 8. 9, 10, 11, and 12. 8, 9, 10, 11, bloody hell. 1, 2, 3, 4, 5, 6, 7, 8. The very first statement says, there is only one student who travels 2 miles to school. Let's find out if that's true. There is only one student who travels 2 miles to school. We see that there is a 9th grader who travels 2 miles to school, and there is also an 11th grader. There are 2 students who travel 2 miles to school. Statement A is not correct. The statement B says, half of the students travel less than 4 miles to school. Less than 4 miles means 1, 2, or 3. Let's find out how many travel 1 mile. There is only one 10th grader who travels 1 mile. We have 2 students who travel 3 miles, a 10th grader and a 12th grader, a 10th grader and a 12th grader. And we have a total of 16. Now second statement says, half of the students travel less than 4 miles, which means 1, 2, or 3. Less than 4 miles, half the students out of 16 would be 8. Let's see if we have 8. Obviously we don't have 8 students, we can clearly see there are only 5 of them. 1, 2, 3, 4, 5. The statement B is not true. Let's keep statement number C. Let's keep statement number C in abeyance. Number D. It says the students who travel less than 3 miles to school are all 12th grader. Students who travel less than 3 miles are all 12th graders. That most certainly is not true. The students who travel less than 3 miles, we have these 2 students, but what about these 3? They're not in 12th grade. Or rather, let me read the question one more time. The students who travel less than 3 miles to school are all 12th grader. No, there is only one guy who is 12th grader. Oh, less than 3 miles. This is getting better and better. One more time. The students who travel less than 3 miles. Less than 3 miles means they have to travel 1 or 2 miles. The statement says that they are all 12th grader. Reality is that none of them are 12th grader. Here's 1 and 2. 1 mile and 2 miles. We have 1 10th grader, 1 9th grader, 1 11th grader. There are 3 students who travel less than 3 miles, and none of those 3 students is a 12th grader. Statement D is utter rubbish. It's balderdash. None of the students is 12th grader who travel less than 3 miles. Now, had they said that, it would have been correct. Number E. Of the students who travel 7 miles or more, half a 9th grader. 7 miles or more, which means 7 miles or more. We have 9th grader, we have 11th grader, a 12th grader. There's 3 so far. We have a 9th grader at 8 miles, and then we have a 12th grader. There's only 5 of them. 1, 2, 3, 4, and 5. There are only 5 of them, so we don't need to waste our time looking at E. E is not the right answer because It says of the students who travel 7 miles or more, as you can see there are 5 students who travel 7 miles or more, and since the problem says half the students, we cannot have half of 5, we cannot have 2.5 child. It doesn't work that way. It has to be an integer. The nature of the problem is such that these have to be integers. And half of 5, even if it were true, would be 2.5. You cannot have 2.5 child. It's rubbish. Answer is C. Let's look at C. Let's look at C. C says, more 12th grader than 11th grader travel 6 or more miles to school. 6 or more miles, alright? 6 or more miles. We have 10th grader here. We have 11th grader and we have 12th grader. But we are not interested in 10th grader. In C, we are talking about 12th grader and 11th grader. So we have to just worry about these guys here. We have to just worry about 11th grader and 12th grader who travel 6 miles or more. This is also why C we're looking at. It says, more 12th grader than 11th grader travel 6 or more miles to school. Well, there you go. That is true. Because there are 3 12th grader. 1, 2, 3. One guy travels 6 miles, another guy travels 7 miles, another guy travels 8 miles. There are 3 of them, 1, 2 and 3. But there are only 2 11th grader. There are only 2 11th grader who travel 6 miles or more. So that is true. More 12th grader travel 6 miles or more than the 11th grader. Answer choice is C. The answer is C. Now the reason why I took so much time in this problem is because what I want you to understand is that when problems like these appear on the exam, they are very tedious, they are very time consuming, they are very laborious, but they are gifts. They are very simple problems. It's just a matter of taking your time. The only reason why you will get this question wrong is because you're trying to do it in a hurry and therefore you're not paying attention to all the details. But the problem itself actually is not that difficult. It doesn't involve any complicated mathematical concept. It doesn't involve any math concept. It's all other than counting. You just have to count, that's all. Number 13. Now listen, before I go to number 13, let's learn this word, abeyance. To put something in abeyance means to keep it aside. When we got to C, I said let's keep C in abeyance. It simply means to keep something in abeyance means we'll deal with it later. Let's postpone it. Let's delay it. I don't want to deal with it right now. That's what it means, abeyance. Did we learn this word, abeyance, in our vocabulary lesson? I'm fairly sure that we did. Abeyance. Or maybe we didn't. Just give me a second. I'm looking at the list of the vocab word. Oh, there we go. Day number 9. Day number 9. Just type in vocabulary. Just type in vocabulary, day 9, and you will learn this word along with some other interesting, useful words that will help you raise your reading score. Because in the reading part of the exam, having decent vocabulary is a must. Okay, and if you're interested in improving your vocabulary, you can go to my channel and look for the vocabulary videos, and you will find a whole bunch of them. Day number 9 is when we learn the word abeyance. And obviously, it's there because it must have appeared in the exam, in one of the exams in the past, and they expect you to know this word. Number 13. How many positive 3-digit integers have 100 digit equal to 3? So the 100 digit has to be 3. Here's your 10 digit, and then we are told that the unit digit has to equal to 4. How many are there? Well, that's very simple. Start counting. Make sure you go slowly. Make sure you don't skip anything. You start counting with all the 3-digit number where 3 appears in the 100 digit place and 4 appears in the unit digit. And you will have 304, you will have 314, 3, 4, 5, 6, 7, 8, 9. 314, 324, 334. There you go. 304, 314, 324, 334, 344, 354, 364, 374, 384, and 394. How many are there? Don't say 9. There aren't 9 of them. 1 through 9 would have been 9, but don't forget the 0. Don't forget the 0. You have to start with 304, not 314. The condition is that the 100 digit has to be 3, which it is, and the unit digit has to be 4, which it is. So you begin with 0, go all the way up to 9. Those are 10 digits. The answer is 10. The answer is A. Number 14. Number 14. We're done with this one. In number 14, they give us a graph that looks like this. 1, 2, 3, and 1. Negative 1. Oh, for crying out loud. Oh, that worked for nothing. Negative 3 and negative 1. Let's give these points name, okay? So we can talk about them. Let's call them A and B. The picture above shows the graph of the line y equals to mx plus b, where m and b are constant. Which of the following represents the graph of the line minus 3mx plus b? Alright, so there are 5 graphs. Our job is to find the one that has 3 times as the slope. Slope of this graph is m. And since this is a negatively sloped line, this line that we given to us is negatively sloped. That tells us that m is negative. M is negative. Okay, m is negative. Next thing that we notice is that it is negative 3 times m. M itself is negative, and negative 3 is negative. Obviously, negative 3 is called negative. So negative times negative is positive, which means the line that we're looking for has to have a positive slope. That's what we're going to do first. We're going to cross out all the answer choices where they give us negative slope. Let's look at the answer choices. In answer choice A, we have a line that is positively sloped. In A, we have a line that is positively sloped. Oh, that is correct. We are looking for a positively sloped line. I forgot for a second. Negative 3 is a negative 3. We have this is a negative quantity, and m itself is negative. So negative 3 times a negative number, because m is negative, this is a negatively sloped line. So negative 3 times a negative quantity is going to be a positively sloped line. So A is a possibility. B is a negatively sloped line. That's no good. B is not the right answer. B cannot be the right answer. C is also negatively sloped. That's no good. D is a positively sloped line. And E is a positively sloped line. So C and B are gone. Now let's look for the next thing. C and B are gone. A, B, C, D, and E. One more time, we're looking for B is gone. It's a negatively sloped line, and C is gone. We have 3 answer choices with a positive slope. The next thing we're going to look for is this part. Okay, once we're done with this part, I'm going to erase this thing. The next thing we have to understand is that in both cases, when x is 0, y equals b, because 0 times m, 0 times anything, 0 times any quantity is 0. So when x is 0 here, y equals b, which is right here. When x is 0 along y-axis. So this point b is what this is, which is 0 when x is 0. When x is 0, y is negative 1. Now here, when we put negative 3m times 0, negative 3m, doesn't matter what this quantity is, negative 3m, doesn't matter what that quantity is, times 0, anything times 0 is 0. So this whole thing is 0 plus b, which means y again equals b. What does it tell us? This tells us that the correct answer, whatever it is, goes through this line. It has to go through this line. Let's look for that. It must go through point B. Now we're going to look at answer choice A, D, and E. See what we can do here. Answer choice A Answer choice A actually does go through that point. Answer choice A does go through negative, so that's a possibility. Let's look at D. D also goes through -1 right here, it goes through it. But E does not. E does not. E does not. So now it's A and D. This is getting to be more complicated than I thought. For some reason I was optimistic. I thought by the time we do this much work we will have narrowed down to the correct answer. It did not happen. So we have to calculate the slope. We have to calculate the slope. The slope of this line is slope equals the change in y over the change in x. The change in y going from A to B, y here is the value of the y at point A. Value of the y is point A is 0. And here the value of the y is -1. So it's 0 minus a -1 over the value of the x is -3 minus 0. So we have negative times -1, we have +1 over -3, which is negative 1/3, which is -1/3. And since the other slope is 3 times as much, since the other slope y equals 3mx plus b, it is 3 times as much, which means it is going to be -3 times -1/3. Negative times negative is positive, and 3 drops out. We're looking for a slope of +1. We're looking for a slope of +1. Among the two answer choices that are left here, if you look at A does not have a +1 slope. In order for it to be positively sloped, it has to go through 1, 1 or 3, 3. And the answer is D. The answer is D. It goes 1 and -1. And therefore, the change in x from here to here is the same as change in y. You see? The answer is D. What is wrong with A is that it is positively sloped, but the slope is not 3 times as much. Slope is same as the other slope. The other slope, the original slope was -1/3. The slope in answer choice A is +1/3. It's not 3 times as much. 3 times 1/3 is 1. The answer is D. I will see you tomorrow, okay? Bye now.